Yeah, so the second part for today's lecture is to look at lab 3. So if you, okay, I have to, I guess. Let me try to, yeah. It's already posted, and then the link to the team assignment also has a tab of lab 3. So you will see who you'll be working with this time. I just want to so note that some of you, because of the RStudio that you're working, you might have to swap out the first few lines with the one that I posted before. If the packet, I guess if the color package doesn't work for you, but if it does, you should be able to knit it without any problem. So let me get the. Right. Yeah, so I'm talking about the first few lines. This is one that I usually post, and it's fine on my computer, but I know some of you need to use other ones, and the ones that we talked about is in the discussion board for chapter 7. There was a yeah, no, not this one, sorry. There was a, yeah, there was the additional, oh, I guess alternative lines that you can use if the lines that I provided does not knit in your computer. So you will just swap out the first few 10 lines with the one that I posted on Moodle almost a month ago. So that should work for you. Yeah, so the lab itself, like I said, is actually replicating the simulation study that is included in the paper itself, is the example 1. Okay, so we have a overall illustration. So maybe one thing you could do is to, before you typing any solutions, you want to knit the document so you can actually see the equations better, because right now everything is typed in LaTeX. It might not be as useful. But this is a summary, I think, of the beta binomial example the paper talks about. And then I also introduced a package that actually can simulate from the beta binomial distribution. So remember the marginal distribution of that X in that example is coming from this so-called beta binomial distribution with N, A, and B. Those are the parameters. So I give you an example of how you can actually generate from them. So if you remember either figure 1 or figure 3 in that paper, they are able to generate from the known analytics solution, right? So that is the R beta binom.ab. That will be the function that you need to use to actually get those white bars. Okay, but the black bars, as you will see, we're going to try to simulate from a Gibbs sampler. So there are certain illustration over there. So a few exercises, just work through them slowly. You have to think through, I think, how many iterations you want, how many draws, I should say, how many draws you want in the end, how many chains you need to run, for example, if you're doing the first method. And then, of course, just follow it closely. So I think as soon as you work through most of the questions, I think the simulation study will be much more straightforward than maybe what you have in mind now. And of course, if you have any questions, just let me know. And like I said, the assignment is on the lab 3 tab. Get it? Yeah, so it's the, oops, yeah, it's the last tab. But in class today, you can work individually or just work next to with people next to you. When you write up the report, you should work with people assigned to your team. Okay, so I'm just gonna put this on, and of course answer any questions you might have, and that will be what we're gonna do for the rest of the class. Okay.